Everyone. Uh, I wanted to welcome you to the technical webinar series, which is at the cutting edge of composites, AI, and manufacturing, and is co-sponsored by AIM for Composites, Ideas, NRT, as well as the SAMPI Baltimore, Washington chapter. My name is Sai Aditya, and I'm the Scientific Program Manager for AIM for Composites, EFRC. Today's lecture is on composites AI. And before I introduce the speaker, I just wanted to introduce the different entities that are sponsoring this particular webinar series. Um, uh, the aim for EFRC as well as the Ideas NRT is headed by Dr. Shrikant Pilla and Dr. Gang Lee, and the SAMPI Baltimore Washington chapter is headed by Sagar Doshi. Primarily, these are funded by the US Department of Energy and the National Science Foundation. The aim for the EFRC is to build an AI-enabled inverse design approach for fundamental understanding and integrated material manufacturing design of advanced polymer composites. The Ideas NSF NRT traineeship focuses on training the next generation of STEM students to develop expertise across multiple disciplines, specializing in AI-enabled inverse design, advanced composites, and sustainable manufacturing. And finally, the SAMPI Baltimore Washington chapter is part of SAMPI, an international professional member society that provides information on new materials and processing technologies through chapter technical presentations. Today's talk is part of our season 4 in this particular series, and it focuses completely on technical talks by distinguished researchers at the cutting edge of composites, AI, and manufacturing. Dr. Wenbin Yu is the Milton Clauser Professor of Aeronautics and Astronautics at Purdue University. He also serves as the Director for Composites Design and Manufacturing Hub and is the Chief Technology Officer of Annalise Swift LLC. His areas of expertise include micromechanics and structural mechanics with a focus on anisotropic and heterogeneous material structures. Dr. Yu has an extensive research portfolio, having authored one book and over 130 journal papers. He has also developed 10 computer codes widely used by tens of thousands across government labs and universities and research institutes. Dr. Yu is a distinguished senior Fulbright scholar, fellow of ASME and ASC, and an associate fellow of AIAA. He received ASC Award in Composites, ASC Outstanding Researcher Award, ASME Boeing Structures and Materials Award, ASME Dedicated Service Award, ASEE Outstanding New Mechanics Educator Award, Georgia Tech Outstanding Young Engineering Alumni Award, and the JEC Innovation Awards. Before I hand it over to Dr. Yu, I just wanted to provide an acknowledgement for this particular webinar series. It's brought to you by the Artificial Intelligent Manufacturing Paradigm, or AIM, which is an Energy Frontier Research Center funded by the US Department of Energy, the Office of Science, Basic Energy Sciences under this particular award number, as well as the National Science Foundation Research Traineeship, Inverse Design Training in Advanced and Sustainable Composites under this award number, which is part of the NSF's Division of Graduate Education. Most of our webinar series can be found online as well as on our website and our YouTube channel. So please be on the lookout for that. These are all publicly available resources that are shared. And with that, I will hand it over to our speaker, Dr. Yu.
Thank you, Dr. Pradeep. Yeah, I really appreciate the opportunity and the invitation to speak on this platform and give us a chance to have a good example of collaboration between University of Delaware and also Purdue on composites, which centered around one central figure, Professor Byron Pipes, as some of you know, and he's also collaborating with me on this effort. I was invited to give this talk, I think last December, but I was busy preparing for my international travel to Israel. So I could not make it. I told them that I promise I will come back and deliver this seminar, but but I was not prepared for the Iran conflict. So I'm glad I made back and also still fulfill my promise to deliver this seminar. I'm now at Purdue and in the United States. So my talk it's centered around the composite AI, which what we have been doing in the past 2 years. And as mentioned, that Professor Byron Pipes is my collaborator. We also have a team from Purdue of students and research engineers and postdocs, and also some research engineers from Anna Swift. And the development of composite AI was initiated by some seed funding from my company, Anna Swift, and also the state of Indiana. There's an organization called the Applied Research Institute. And what we're trying to do is that basically when ChatGPT become basically a fashion in town, and we try to use large language model to democratize the unassisted technologies with three goals. First, to provide at least 90% of tech support for Anna Swift just by using AI, and also integrate the Anna Swift simulation codes. Particularly, we have two codes used extensively in industry, WebS and SwiftCom with large language models, and also democratize the use of Anna Swift simulation technologies so that people don't have to know finite elements, don't have to know micromechanics, even composites, but they know how to ask questions in their own language, then they can get answers. That was the idea. And the idea is really like to use the system like ChatGPT, but has the authority endorsed by the real experts, and also precision guaranteed by sophisticated engineering simulation softwares. And we are in the composite field. We know that in the past maybe 60 years, we developed a lot of knowledge. We have books and papers, take reports, database, and also the simulation tools. And we have a lot of codes, and it's all available. But the problem is that we have access to difficulty related with access of the data of tools. They are located in, let me see, why they going automatically. They are located in different places, and they are siloed and disparate data, and not easy to access, not easy to retrieve, of course, not easy to use. And also segmentation tools, we know it belongs to different vendors and different license mechanisms, and sometimes even, hardware specific. So it's become not easy to access and use. And also simulation tools, they are disconnected. Usually, if you want to do the entire the life cycle or the entire workflow for the composite, you need multiple tools to connect together. That's what the digital twin and ISME, what we are doing there. And that's the first part of the challenge, what I have seen based on my observation of this several decades involved in this field. And also second challenge related with composites is access to human talent. First is that many, they do not have formal training. We do know that, I don't know Delaware, but at Purdue, our composite courses start from graduate level. So, but most engineers are, they just have their undergraduate degrees. So which means many of them don't have a formal training of composites. And we do know that when you want to get reliable simulation results and damage results, failure results, and all that, usually you need a PhD level training to get confident results. And of course, PhD are trained at very narrow domains, and to design a good composite product, you need multiple PhDs, then that's not affordable for small companies. So access to human talent is also a problem. The last problem is loss of expert insights. And I use two pictures to illustrate my point. The first is directly related with the Delaware Composite Center, the highest honor in our field, the mechanics of materials made of excellence. And we have 4 pioneers incurved on this. We know 3 of them are all deceased. They all passed into eternity now. They are not with us anymore, which we are fortunate still have Steve Tsai around and close to be 100 years old now and still professionally active. Actually, recently they helped me to correct the answers related with double-double on composite AI. So that's what the Professor Tsai has been doing. And, what I was hoping that when these pioneers and these giants, they left a lot of knowledge, their books, their papers, and some of the series encoded in simulation tools. But when they passed away, we always say there is a big loss to the community. So I think they are not only the books and papers and the simulation tools, whatever have the knowledge intent there, and also in their brain, there are also a lot of knowledge and the expert insights they brought with them, and that has not been captured. And also I have another photo here, also directly, has a close relationship to Delaware Composite Center and Professor Jack Winson, and unfortunately passed away very recently. And also Professor Seki San and Zhou Zhou, they are all, made significant contributions to the field. But neither Professor San nor Professor Zhou are professionally active, which means that I would like to see, if they're still professionally active, if we could have a system or mechanism to capture their insights before they are no longer available or no longer professionally active. So that's the loss of expert insights I'm talking about. Same is true for companies. You could have a very senior engineer or employee, and they will retire someday or change jobs. They have something documented that left behind. That's okay. But there are a lot of knowledge that which is intrinsic to their experience. They may take with them, and if we don't capture it in a good way, and with the AI, there is a possibilities. So how to somehow elevate this situation. We can capture some of the expert insights. So in facing these challenges, my proposed solution was first, all the data we see is siloed and disparate. How do we consolidate them together? Of course, not only public data, we also have proprietary data, which is private to companies. And this data, you will find out I classified them into 3 types of data. First is the static data, which is documents. The content, is written and fixed. And databases, those are what I call the static data. Then you have dynamic data, the models. You have certain parameters. Then they run on these parameters. You will get the outputs. Those are what I call dynamic data. Basically, it's the physics-based or AI machine learning trained models. Then another set of data, what I mentioned, is the expert insights. And those are the knowledge available in the expert's brain, but not articulated in documents or implemented in simulation tools. These are the most valuable part of the knowledge, and also not easy to access, and also to capture and even transfer. And that's the first part of our solution. Second part of our solution is not only put all the knowledge together or the information or data together, but also how to democratize them in such a way that, whoever need answers, they can get answers, not necessarily have to have a very solid training. And this is what I call democratize the delivery of the expert knowledge. And of course, once you put everything together, you want to intelligentize the consolidated data. You have text, you have images, you have simulation tools, and the most democratized way is that everybody knows how to type, or speak, use their own language. So if we can use this expert knowledge to deliver answers using natural language in chat interface like ChatGPT right now, so that would be great. And third is, as we said, that we need human experts in the loop for quality control. That's very important for us to build an AI-powered expert system. And we need the experts to approve or to certify the data entering the system. And we also need the experts to validate and correct the wrong answers. Just like what I mentioned that recently, I just talked to Steve Tsai. I say, hey, there's some people ask questions about double-double. Those are the answers provided by CompositesAI, but I'm a little bit suspicious about the correctness of the answer. Can you help correct them? Then he's gracious enough, and he, go ahead and correct those answers. Then I put back to the system. And these are our proposed solution. And when you look at this picture, it's architecture we have been building our solution around. And as we say, the central to our solution is let me get the map. The central to our solution is the composite tuned large language models. And that we can take a commercial existing one, whether it's OpenAI or Gemini or whatever you want to take, all the open source one. We test both. And of course, based on the large language model, what you have, you can do further fine tuning, and also you can do other stuff you want based on the computational resources we have. Then for the system, we have two levels of users. You can call it human users. One is the regular users, like what they usually use for ChatGPT. You can use the system, and you can also provide the feedback to the system. Another level is composite experts, and you can contribute knowledge, and also you can certify the knowledge, and also, of course, you can use the knowledge, and you can also help correct the answers to improve the system. And for the composite AI engine here, it has access to 3 types of data, as I just mentioned, in terms of static data. Usually we use the mechanism called the retrieval augmented generation, right? And also you could have dynamic data. Those are the simulation tools, and you use function calling through APIs, or recently there is a mechanism called scales, and we're also testing that right now. And then you have certain types of tacit data. Tacit data is really, because it's not documented, it's not incorporated into simulation tools yet. So what we do is, through the interaction between the experts and the normal users, we convert the conversations into structured text that the AI can use. And the more details we described in your article on JEC Composite magazine, just very recently published. And next, I will use a few use cases or demonstrations to show how you can, to show the performance or the usage of composite AI. First is that you can obtain more accurate answers from the intelligent test expert knowledge. And we have a simple question here. Everybody who is in composite field maybe know the answer, not necessarily. Basically, how to compute the upper bound of Young's modulus of a two-phase isotropic composite. And you can ask the same question to CompositesAI and also ChatGPT. CompositesAI, it was talking about the rules of mixtures, void bounds, many of you know, but some of you may not know that this is not the upper bound. This upper bound assumes the string is uniform and all that. Note that this is strictly valid when the both constituents have the same Poisson's ratio. If the Poisson's ratio differ, the actual upper bound is slightly higher, is given by a more complex expression. If you further ask CompositesAI, so what is the more complex expression, it will give you. But if you go to, let me see here. If you go to ChatGPT, you can ask the same question. That's no problem. Let me see whether you can fire up here. Yeah, either way, you ask the same question, and of course, it was said, but they say it's always valid upper bound only is void bound, which is not correct. It's, this is a simple, simplistic rules of mixture, and I purposely wrote the paper on this. Say that's not right, and you got a quadratic term related with difference of the Poisson's ratio for the upper bound. So then you will see that is really not, they only trained on whatever available on, Wikipedia, the public text. They not necessarily have the expert knowledge. That's the point why we want to do composite AI. Okay, so first you can obtain more expert-like knowledge. Second is that you can use it to study. This is actually a real situation. There is a student and take our mechanics of composite course called AE 555. It has a lot of questions, but it not necessarily the student want to always bother in the TA or the instructor for this case is myself. So then the student finally realized, yeah, that the professor already created composite AI, and he has his book already there, all the course material there. Why I don't ask, composite AI the questions? So they ask a simple question that in my class, because it's an open book and open notes, open everything when you go to the final exam. So it really requires you to have a good understanding of the material. So in my class, when we talking about the classical lamination theory, I talking about this, the traditional way of classical lamination theory relies on two self-contradictory assumptions, and students sometimes have difficulty to get it. And if you ask composite AI, it will answer you that these two self-contradictions. One is the plane space assumption. Remember the Q matrix, that's a plane space reduced the constitutive stiffness matrix. Then you have the Kirchhoff assumptions, which is essentially a plane strain assumption. And the plane stress and plane strain cannot coexist except the Poisson's ratio goes to 0. Otherwise, even for isotropic material, you will not have plane stress and plane strain goes together. And if you ask ChatGPT the same question, then it was talking about all the assumptions, classical lamination theory make, but it really didn't go directly address the self-contradiction within the theory itself, which is the plane space assumption, Kirchhoff law of assumption. And let me see whether I can quickly fire it up. Yeah, it's here. Sometimes just there. Yeah. So they basically talking about all the assumptions and the difference between this and the 3D elasticity. That's a typical ChatGPT, and usually it's longer their answers and not necessarily direct to the point. Okay, the third example is showing that we can take any machine learned models. So what we are doing here is build a platform, not necessarily train a specific model. So here we show that at this moment there may be hundreds of models are training right now, but usually people just the life of these models end on the publication. Once you publish paper, somebody will maybe upload this supplementary files to the article. Somebody even don't bother to do that. But no matter what, we usually don't use these models, which some of the models could be very good to answer questions. Here, what we did is to take a model trained by another professor, Professor Liu, at UT Arlington, that several years ago, I say, send me the scripts. Then we dump to composite AI, and then we can use it to answer questions. Not only answer questions, we can do the incremental training, because when you train a model, you have your parameter range you set up there, but the user may ask questions outside of your bound. Then the system can tell, oh, yeah, that's not the model what I trained for. Do you want to use the corresponding physics-based simulation? will go to physics-based simulation state, and then we can capture that data. And once the data, the number of data, accumulate to say, I don't know, I don't remember what the threshold we put there, about 500 or 1,000, we will update our surrogate model, machine learning surrogate model. And you can look at what we did here. So basically here we say, I want to find the effects of fiber volume fraction on thermal conductivity of woven composite. So can you help me? Of course, it will have typical knowledge there. And then I say, can you carry out the simulation to support this answer? They say, yeah, but you need to provide me input parameters. Then I say, just proceed with default parameters. Then they will give me the answers. Then I will also ask them to, they default parameters, only one set of the parameters. They say if you want to know how this value change with different volume fractions, you need to run different values. I say, yeah, please run different values. So the system know how to do a batch, batch run and all that stuff. So it will list all the, all the different volume fractions and corresponding in-plane, out-plane thermal conductivities. Then I say, can you also optimize for me? Say, I want the minimal in-plane thermal conductivity while maximum out of plane conductivity among all the inputs you can explore. They can do that. So that basically shows the point that once you have a machine learning model, you can dump it here. That can help you to answer questions, from the users who will be interested in your model. And that really significantly extend your utility and also the application domain of the models, of course, the impact of your models. And this example is a real story behind it. Some of you may know that those composite giants like pioneers, like Professor Pepys, they are trained before finite elements. So sometimes if we need some sophisticated micromechanics model scale simulation to validate his intelligent guess, he will come to my office. That would happen 2 years ago. Come to my office, they want to know the longitudinal shear modulus of fiber reinforced composites. So he gave me some numbers. I open my code and I run this crazy finite element model, mesh it, and run the simulation, send him the results. And then he come back and say, these numbers are not realistic. Can you change some inputs, say how it looks like. So I do it again. And that was, at that time, CompositesAI was not available. Now he does not have to do it this way anymore. Let me show what he can do now. Now, say I want to predict the longitudinal transfer shear modulus of UDFR. Say, can you help me? He say, I can help, and provide me some inputs. I say isotropic fiber and Young's modulus, Poisson's ratio, and the matrix. Of course, you could be isotropic fibers. That's not the point, and not important at this point. And also hexagonal packing and the volume fraction, 68%. It will give the results. So those are the results, which is exactly like what I did, run the sophisticated finite element model for him. Then this line actually directly from his email. He said, your numbers are a bit high. Try EF equal to 231 and Poisson's ratio and EM and the Poisson's ratio. And of course, that the AI will clarify some questions, say, it looks like, I don't know whether the matrix is isotropic or not. I say assume isotropic, then it will give the results. So based on what you have, also isotropic, it will give the numbers here. And now there is no so-called created finite element model, at least to the end user. And those are exactly, the information provided by Dr. Pepys. And now this is directly copy and paste from his email, and the system can take the information and deliver answers. So in that sense, I created something that replaced myself. Is that good or bad? And you can judge. I think it's good. personally for myself, and I think my time can be better. I mean, it's not a complaint. My time can be better explained to create a new series and add new capabilities to my course and to my series, like what I have put into my book here. Not necessarily run finite elements simulations, right? And this stuff can be done by AI now if we can guarantee their accuracy and make sure they are done by experts. Okay, so the next example basically showing that actually AI can do integration of various tools to a workflow. We know that ICME and digital twin, there are significant effort. What they're trying to do is really to connect different tools into a workflow so that somehow to cover the multiple, whatever design analysis prediction needed through the whole life cycle of composite for our field, for example. But those are not trivial tasks because the codes could be changed and you have to deal with inputs and outputs. And they are really tedious and also not very do not have a lot of intellectual value in my mind. And once Abacus change the input, you have to change your integration, modify integration again. But within AI, actually, you can instruct at a more abstract level as an expert. For example, this is a simple example. Say when you do a prediction of woven composites, you need to start from fiber and matrix to get the yarn properties, then take the yarn properties using the woven architecture to predict the woven properties. So there are two steps. And usually we do it step by step. And once you do it once, then the AI can recognize, they can link these multiple steps into one workflow. For example, here I'm talking about that can you calculate the effective properties of two-phase materials? So for fiber and matrix, that's basically try to predict the yarn property. Ask them to use 0.6 as the volume fraction. Then say and use this as yarn properties. And I want the system to calculate the effective property of flexible a textile and with a plane wave, I believe, plane wave and certain spacing and matrix properties, and that's sufficient for plane wave. Then it will do the calculation. So now I say, can you integrate the above two steps into a workflow to predict the property of a plane wave composite with with the inputs in terms of fiber property, matrix property, fiber volume fraction, and woven architecture. And it can do it, but the problem is AI is kind of like lazy. They find out the numbers I gave is exactly the same as the previous two steps. They didn't do calculation at all, just list the values. Say, do the first step, you need to do that. Second step, you do that. And, those are the results and the summary of the results. So I try to force it to really do a real kind of a linked workflow. The real calculation, I say, use this workflow to predict the property of a woven composite. I change the numbers. Then actually it will call the simulation codes, do it step by step, which is exactly what I needed. Of course, if you already have calculations, AI is supposed to be intelligent enough to recognize that. Don't have to rerun the physics-based simulation there behind it. And you can also use CompositesAI to create your own AI agent. As a professor, you can create your own agent to capture all your knowledge, all your tools, whatever you have there to provide answers to your students or to your colleagues. And as a company, you can do that. That's what we did for Anna Swift. That's how we get started with this project. And if you go to CompositesAI, you find out we have different systems there. So it's a system of systems. We have the general model called CompositesAI, and also you have Anna Swift AI. You can ask questions, specific to Anna Swift, which is my company related to vibes and pre-vibes, and how to generate the input file, how to run the simulation code and all that. And what was surprising to me, which is a trend that you guys maybe also experienced that in the past, users usually, send us, once they get the code, they will ask questions, usually send the email and all that stuff. And one day we had a customer, they download the code for quite a few times, and maybe 1 or 2 months. We are saying, you guys don't have questions? Normally others have questions. I say, yeah, we have some questions, but we went to answer with AI, we figured it out with the help of AI. So people starting to uh, prefer to ask AI first and to get answers from the AI and instead of ask us, which is interesting, although we made us available. And another one is this is the last demo and the use case of CompositesAI. But instead of force everybody go to compositesai.com, that's where CompositesAI is located. We can bring CompositesAI and also its agents as plugins to a social media like Technic Forum or whatever. So this this has the benefit of you have human AI interaction, not only yourself and others. For example, for a professor, if you teach a class about the composites, you could have composite AI as a participating. You can send whatever rule to that, but just a register user, and also the professor and the students they can discuss together, and that would be good. At least you have two benefits because the professor or TA will not be announced online 7/24, and their working schedule is different from student schedule, right? Students usually work midnights and they want to ask questions, but professors are not available. But the students can ask AI the questions, and the professors the next day when he get online, he or she get online, he will say, yeah, the AI answered pretty correctly, so it will be sufficient for the student. If it's not correct, then the TA or the professor can correct the AI's answer and say, hey, there are some issues there you should pay attention to. So this also teaches students to debug AI answers, which is a capability needed for us in this age right now. Of course, similar thing applies to take support for a company. A real human expert cannot be online 7/24. And particularly, for example, for our course used internationally, different time zone and all that stuff. And if they need an urgent answer, AI will be always available 7/24. And also the real human experts can always go back to say, hey, yeah, that's good enough, kind of like a certified. And also that there are some mistakes in this answer. And of course, the experts will also go ahead to correct the system. Next time the same questions asked of AI, it can produce correct answers. And we have a few examples here. Let me say this. This is the first example, which is interesting. And that is, I showed this to Dr. Pipes. Perhaps I say, perhaps you can just chat with AI on a platform, just like what you normally do. And then perhaps, what should I do? I say, you just ask question, ask who is, Byron Pipes. I say, oh no, I don't want to ask him. Ask myself. Then how about who is Steve Tsai? Then Composite AI can provide the answers. Then they say, where do you find the information? The AI will tell that where the resources. They find the information. And we have also another example here. That's the first example. I show the capability to Dr. Pipes regarding that you can use it on the platform. By the way, this is a website called community.cdmhub.org. That's we created, I think, maybe 1 year ago to specifically test this idea, how to bring AI into a social media like platform. And this is a student from Europe asked questions about the composite simulation, particularly on composite beams, which is my area. So I answer him directly. That's my old traditional practice, right? When a user or customer has a question, I answer them. And, then I realized, hey, why I don't let the composite AI answer it? So I say, composite AI, can you answer this question or not? They say, oh yeah, of course, AI is always 100% overconfident. So certainly they will answer it. And I look at the answers, actually pretty accurate. And I think there is no technical mistakes here, and the English clearly much better than my writings. Then there is another student tried the kind of like hold suspicious. That was, this is last summer. They tried the ChatGPT, that was O3. The same question, they just copy and paste the student questions, the real question into ChatGPT and provide answers. You can go look at the answers. Because me is the real expert on this subject. I look at the ChatGPT answers. They sort 46 seconds there. There are at least more than 10 mistakes from ChatGPT answers. And we also test the possibility you could have multiple AI robots into one discussion. Here, if you look at that, we have Anna Swift, the robot there, AI chatbot, and also have CompositesAI chatbot. And the human, we have admin as a human and to test it. And that's also good because you cannot just have a general model for customer support or for calls, for example. You have all your course material. You want to make a spatial agent. So you need to plug in use a spatial agent to your discussion group. So this platform has the capability to plug in whatever the chatbot you have created on CompositesAI to your discussion board. Okay, so this slide summarizes what we did related with CompositesAI. First, consolidate composite knowledge. Of course, it's a work in progress. And currently, my knowledge is there, and Dr. Pipes is also putting his knowledge there. And we try to accumulate more and more. And also intelligentize the composite knowledge. That's mainly done through the large language models. And democratize use of composite knowledge. If you go to CompositesAI, you'll find out you can either speak or type in whatever language you're comfortable with. It will give you answers. And it has capability to create customized AI agents. And we basically try to provide kind of like an AI facility everybody can use if they want to play with it. And it can hook up to different large language models and even the open source models. And also in the future, currently it's not available yet, to provide a marketplace for all the AI agents so that, you could have different professors or different experts provide the technical support to, technical answers to the community, like Professor Peeler. He make an agent here and myself and the agent here. You choose from whom you want to ask questions. And some of the experts may, charge for their answers, like 5 cents an answer or something like that. This platform has potential to do that. Of course, an important part is to immortalize experts' insights so that even after I retire, my knowledge can continue, or my AI assistant can continue to serve the community, which is an important part. That way, we can build more and more knowledge, hopefully, that make the field progress quicker, and also perpetuate companies' competency and also legacy, so that the company will not, because of sudden loss of a senior engineer or employer, and without carefully document all the knowledge he has, and just through using the system that the conversation and those can be captured and converted to the tacit knowledge we're talking about. If you're interested, you can scan the QR code or go to compositesai.com to try it, and also give us feedback. And AI is such a big area and also so rapidly progressing area, and we need your inputs to make it better. The last, we have a 1-minute video. If you've been to JEC this year, you may saw the video. I will play with it. I will play it. Let you see the general. It has a pretty good introduction and summary of what we want to do about the CompositesAI, but I need to make sure the composites.
The composites world is changing faster than ever, but critical knowledge is scattered. Tools don't talk to each other, and experts are stretched thin. Engineers jump between disconnected software, manual workflows, and isolated data. Progress slows. Innovation stalls. Introducing CompositesAI. One environment, one expert system built on decades of validated engineering knowledge. It can consolidate everything, from technical publications and textbooks to simulation tools and expert insights. No guesswork, no fragmentation, and human experts stay in the loop, ensuring accuracy, authority, and trustworthiness in every result. Run multi-physics simulations, explore design options, and automate repetitive workflows, all from one comprehensive system. Try CompositesAI today at compositesai.com.
But that's all I have, and I will be glad to take your questions.
Before we get to questions, Dr. Yu, we want to thank you, first of all, for giving this excellent talk.